Welcome back to the office. We want to take a look at one more example for section 6.8. And I really like this example because it's going to give us something that we should already know. and maybe we don't, and that's absolutely fine. So we have a really nice number that we're all familiar with. Super familiar with. Ooh, I changed the example slightly, so I'll have to follow along carefully there. So it involves a number that we are interested in. So I'm really excited about this. So let's take a look at this example. We have in here the limit as x goes to 0 from the positive side. Actually. Okay, yeah, sorry. We have as x goes to 0 from the positive side. This value here is going to go to infinity. So we're ending up with infinity in here, and then 2 times a number approaching 0 is going to go to 0 as well. So this is going to give us the indeterminate form of infinity to the 0, which is an indeterminate form. So we say, okay, well, how do we handle that? How do I rewrite this as 0 divided by 0 or infinity divided by infinity? And what we're going to do is we're going to begin by assuming, which can be, not the best thing to do. So we want to assume that the limit exists. And when we assume that the limit exists, we can say that the limit as x goes to 0 from the positive side of 1 plus 1 over x to the 2x is equal to some number L. The limit is L. Okay, so we've made that assumption. What we can do then is we can manipulate this a little bit. I can take the natural log of both sides. So I can apply, or I can bring natural log out. So if I wanted to take the limit as, let's see here, x goes to 0 from the positive side of the natural log of 1 plus 1 over x to the 2x. I can apply that natural log to L, and that is perfectly fine. This equality will still hold. The beauty here is that what I end up with is, so I want to evaluate this left-hand side here. I can pull the 2x out. So this becomes the limit as x goes to 0 from the positive side of 2x times the natural log of 1 plus 1 over x. And you might notice that this gives us 0 times infinity, right? This goes to 0, this is going to still go to infinity, and this is still an indeterminate form. However, we have really nice ways of handling this. So this limit is equal to, let's see, take a limit as x goes to 0 from the positive side. We're going to cleverly rewrite 2x as division by 1 over 2x. So natural log of 1 plus 1 over x divided by 1 over 2x. And this gives us the indeterminate form of infinity over infinity. So that's wonderful because now I can apply L'Hopital's rule. And being able to apply L'Hopital's rule is going to give us still the limit as x approaches 0 from the positive side, derivative of natural log here. So a big fraction, this thing, 1 plus 1 over x goes in the denominator, and the derivative of this goes in the numerator. So negative 1 over x squared. Let's see here. That's fine. And then in the denominator here, the derivative of 1 over x is again negative 1 over x squared. So I'm going to end up with an additional factor of 1/2 times negative 1 over x squared. So now I just need to perform some simplifications. So this is equal to the limit as x goes to 0 from the positive side. Division by a fraction is the same as multiplication by the reciprocal. So I have negative 1 over x squared. And actually maybe trying to avoid the appearance of complex fractions, I can write this as negative x to the negative second divided by 1 plus x to the negative first. That's my numerator. And my denominator is going to be, the reciprocal would be 2 times, right? This is just one big fraction, 2 times x squared over -1. So our negatives will cancel out. The x to the -2nd and x squared will cancel out. So I get that this is the limit as x approaches 0 from the positive side of my 2 goes in the numerator, and I have 1 plus x to the -1st in the denominator. Now this is going to go to infinity. So this isn't bad, right? The denominator is going to infinity, so overall I'm going to get that this is equal to 0. I should be at a place that that's pretty clear. The thing is that we are now saying then the limit as x goes to 0 from the positive side of the natural log of 1 plus 1 over x raised to the 2x is equal to 0. So this 2 did not make a difference. It appears. Let's see here. Yeah, this, the 2 gets pulled out. Yeah, so it's 0. All right, I was thinking that that would play a little bit more of a role. I guess that it is somewhere else that the 2 would play a role. Or maybe I made an algebraic mistake, and you feel free to point it out to me. All right, so this is 0, but we said that this is the natural log of L. So focusing on this thing, if the natural log of L is equal to 0, we can rewrite this in exponential form and say that e to the 0 is equal to L. Excellent. Yes, e to the 0 is equal to L. And this would give us the limit as x goes to 0 from the positive side of, right, get rid of the natural log. It's just 1 plus 1 over x to the 2x is equal to L, which we said is, I guess we didn't say, e to the 0 is 1. So we get that this limit is exactly 1. So that's not super duper interesting in terms of our final result. I was thinking that it involved one of our favorite numbers, but I was slightly distracted. The limit here is different than what I was thinking of. So if we were to consider the limit as x goes to infinity of 1 plus 1 over x to the x, this actually gives us e. And so we could take a look at that as well, because this is going to give us 1 to the power of infinity, which would be an indeterminate form, if we recall 1 to the infinity, an indeterminate form. So we could do the same approach on that particular limit as well to find that value. All right, but that's all that I wanted to share, and that is the end of section 6.8, and thus the end of chapter 6. Woohoo! So have a wonderful day. I will see you guys again soon back in the office, workshop, or the classroom.